Hello students, welcome to Sources classes. Today we'll be solving the ISI MSQE question paper from the year 2016. Today we'll be solving question number 5 and question number 6 from the ISI MSQE paper. So let's start with question number 5. In question number 5, it is said that the smallest integer that produces remainders 2, 4, 6 and 1 when divided by the numbers 3, 5, 7 and 11 respectively is 104, 1154, 419 or none of these. So we have to find out the smallest integer which when divided by the numbers 3, 5 and 7 and 11 respectively produces the remainders 2, 4, 6 and 1. So let that number be, let the required number be k. So as per the given conditions, we get that when k is divided by 3, then the remainder that we get is 2. And when the same k is divided by 5, the remainder that we get is 4. When k is divided by 7, the remainder that we get is 6. And when k is divided by 11, the remainder that we get is 1. Now we know this is a given condition. Now we know that the powers of 3, so when we take out the powers of 3, then the unit digit come in the order of, in case of 3, it comes down to 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 27, so the unit digit 7, 27 into 3 it is 81, so the unit digit is 1, and then it is 3 again, and it goes on like this. This is the loop that continues. So if the remainder which is produced when the number is divisible divided by 3, the remainder is 2, so in that case the unit digit in each of the cases will be this unit digit plus 2. So the unit digits that we have to consider over here, the number that we are supposed to find out, the unit digit of that number will have the digits 5, 9 plus 2 is 11, so the unit digit is 1, 7 plus 2 is 9, 1 plus 2 is 3, and 3 plus 2 is again 5 as the previous number. So these are the unit digits that can be the unit digit of the required number. Similarly for 5, the unit digit is always 5. Now we know that the required number that we are supposed to find out, when that number is divided by 5, we get a remainder of 4. So in that case the required unit digit has 9. Similarly for 7, the first number is 7 to the power 1 is 7, 7 to the power 2 is 49, so unit digit is 9, 7 to the power 3 is 49 into 7, that is 3, and then the next unit digit has 1, and then it is 7, and it continues like this. Now when the required number is divided by 7, the remainder that we get is 6. In this case, so the required unit digit will be 7 plus 6 is 13, so unit digit is 3, 9 plus 6 is 15, so unit digit is 5, 3 plus 6 is 9, 1 plus 6 is 7, and 7 plus 6 is again starting, which is this number. So the unit digit here, required unit digit is 7. So we see in all these cases, the common case is when the required unit digit has unit digit 9. So this is the common case. So out of these options, out of the options, only option C 419 has a unit digit 9. So now let us check out for this very number. So now if we divide 419 by 11, in that case 3, there is 33, 8 comes below, 9 comes below. Now it is 38, 88, and the remainder is 1, which satisfies this condition. So 419, which is option C, is the correct option. Now let's move on to the next question. In the next question, which is question number 6, it is said that given 30 people, the probability that among the 12 months there are 6 containing 2 birthdays each and 6 containing 3 each. The various options are given over here. The first option is 30 factorial upon 2 to the power 6 into 6 to the power 6 into 12c6 into 12 to the power minus 30. This is the first option. The second option is 12c6 into 30c12. This is the second option. The third option is 30 factorial by 2 to the power 6 into 6 to the power 6 into 12c6 into 1 by 30c12. This is the third option. And the last option is none of these. So now let's find out the total possibility. Now it has been given that given 30 people, the probability that among the 12 months there are 6 containing 2 birthdays each and 6 containing 3 each. So let us find out the first. Let us find out the total possibilities of the 30 people having birthdays in all the 12 months. So the total possibilities of 30 people having their birthdays in the 12 months. So the first person can have so in the first month, so the first person can have his birthday in 12 ways, and the second person can also have his birthday in 12 ways in the 12 months. So that goes on for all. It will be up till 30 times, up till 30th people. The cases are like this. So the answer is total possibilities 12 to the power 30. Now in our case, we are needed to find out the probability that among the 12 months, 6 months will contain 2 birthdays each and 6 will contain 3 each. So in that case, required cases or favorable cases will be equal to 12c6. Out of the 12 months we take 6 months upon 30 people, which will be rotated on each other, into 2 factorial into 2 factorial to the power 6 and 3 factorial to the power 6. This is the option that we are looking for in here. Upon simplification, this will come down to 12c6 into 30 factorial upon 2 factorial is 2, so 2 to the power 6, and 3 factorial is 6, so 6 to the power 6. This is the number of favorable cases. So the probability in question, required probability, is favorable cases is 12c6 into 30 factorial upon 2 factorial into 2 to the power 6 into 6 to the power 6, and the total number of cases is 12 to the power 30, that comes in the denominator. So this is equal to option A. So today we have solved question number 5 and 6 from the ISI MSQE paper of year 2016. We will be solving the next questions in the subsequent videos. Till then, keep watching Saurabh's classes videos for more solutions and content. All the best for upcoming examinations, and thank you very much.